Good morning, everybody. I hope you can hear me okay. It's great to see you all here this morning. Really warm welcome to you all from Adelaide in South Australia. I say that because we have a great deal of registrations from around the world. Vitomir, my colleague, has managed to smash the registration record this morning. It's like there's some kind of interest in AI out there. I'm not quite sure if that's the thing. I think maybe it's just you, Vita. So fantastic to see everybody here this morning, and a really warm welcome to you all. I'd like to introduce my colleague, Dr. Vitomir Kovanović. He's from the University of South Australia. He's also attached to the Unit of Education Futures and the C3L, the Centre for Change and Complexity in Learning, he, as well as doing many other things. I'm sure you can look up his bio and be impressed by him with the AI. Being so in the news recently, he's been a very busy man, but he's made some time to speak with us this morning or this evening or this afternoon, wherever you happen to be. So once again, thank you so much for coming along and getting involved in this session. So before we start, I would just like to acknowledge that the land we meet on today is the traditional lands for the Kaurna people, and that we respect their spiritual relationship with their country. We also acknowledge the Kaurna people as the traditional custodians of the Adelaide region. And for those who are not from Adelaide or South Australia, that's this little area just down here where my pointer is. I hope you can see that. And we respect their cultural and heritage beliefs, and they're still important to the living Kaurna people today. So once again, thank you so much for coming along this morning. Really looking forward to this session with Vita. And I'll hand over to you, Dr. Vitomir Kovanović. Thank you.
Thanks a lot, Stuart, for the introduction. Welcome, everybody. So let me just first share my screen. I think you should all see my slide. So the topic of today is teaching and learning with in the age of AI, and what are the opportunities there? What we can do with all of this recent mess that happened and that we've seen in the news. So first of all, I'll briefly describe a little bit of what is AI and how it came to the place we are, and then talk more about the impact on teaching and learning. And Stuart and I had a bit of a plan to have actually a bit shorter presentation and then focus more on Q&A and discussion, because this is all new to everybody, especially how this will impact education. So I think we thought it'd be better to have more focus on the discussion part. So first of all, what is artificial intelligence? It's a branch of computer science. That's the important thing to know. It's not something special. It's just like a study of operating systems or networks or programming languages. This is just another branch of computer science. It's a very old branch. As soon as people realize that computers can, you can build machines that do interesting things, that you can build them to do something very useful. And so it's just the name of technology. And the question we often hear, well, yeah, that's not really intelligent. Yeah, I know your smartphone isn't smart either, but nobody really makes a fuss about that. That's really irrelevant point. This is just the name of technology that was picked in the 50s, so they can get, it's a cool name, and they will be getting funding from United States Department of Defense. That was all. So the same way you have iSmart, this, that, whatever, that's the same thing, just a bit older. But the idea of building intelligent machines is very, very old. In fact, you had the first programmer, somebody, first person who's recognized as a programmer was the daughter of Lord Byron, and she was Ada Lovelace. She was working with Charles Babbage on his analytical machine. And she was the first one to realize, yeah, this thing is cool. It can do all kinds of calculus computations and, process numbers. But in the future, we will see machines that will be able to write poetry and do more interesting things. And that was a bit of a, point to her father, who was a poet, right? And so the idea that machines will be able to do clever things is very old. Now, when it comes, what do we mean by intelligence? Well, actually, there is not a clear definition. If you try to look up in psychology literature, what is the definition of intelligence? There is no clear definition of intelligence. Even though it's such a fundamental concept in the psychology, literally the most important construct in psychology, we more know of the things that constitute intelligent behavior. And first one is ability to learn. So intelligent systems, beings, whatever, they're able to learn new things. They're able to adapt to new information, to new environment, to other agents, and so on. They're able to recognize patterns. So that's why, for example, when you see a Mensa test or anything like that, it's basically a pattern recognition test. So that's the idea. So once you have a new situation to recognize patterns in the new environment, and clear one ability to solve problems. So those are the things that constitute intelligent behavior. Self-awareness is another thing, completely another thing, right? You can't have intelligent behavior without that. And that's really, so in AI, really the focus isn't on can the machine feel or think or any of that sort. The idea is that they show intelligent behavior. So it's a very behavioristic view on things. And in AI field itself, I mean, been developing over, 70 years now, there are really two branches. And the first one we can call symbolic AI, which was all based on logic, the idea to build theorem provers. Like that was the first thing. They built a machine, they said, here are all the mathematical laws, and we give you a new theorem, and you can say, is it true or not? So the idea of having very induction and deduction mechanisms there to be able to process logical information. And often the idea was searching for solution. So that's how Deep Blue, for example, was a bit Kasparov in the 90s. Typically in chess, whenever I want to make a move, I have about 30 options. And, it's a 30 option for my turn, then 30 options for an opponent. So that's about 900. So when it comes back to me for my second turn, there is actually 900 options already. So you can see how the number of combinations grow ridiculously fast. How Deep Blue plays, it has all the different expert knowledge to actually narrow down the search to maybe 3 or 4 options. And now with the 3 or 4 options, he can think 10, 15 moves ahead. And he's searching for a good position. So this old AI was really about having all these logical inferences and cascading effect, and just, being clever in searching well. While that's been developing, up to 90s, that was really the predominant way of doing AI. And there's another one which is really called data-driven AI or machine learning. And the idea is not to don't try to build something that's so clever and coherent, consistent. No, don't do that, but try to use the data. And then data is messy and inconsistent, and there will be all kinds of conflicting information and so on. But, you can deal with that in some probabilistic way. And actually, over time, really, this is the way that really prevails. And in many ways, there is definitely value in logic and symbolism and this approach, but it really fell out of favor to machine learning. Now, what we mean by machine learning? We'll mean learning specific models of something. So let's say you want to predict the house price. You can have a very, very complicated model, but you say, let's try something simple. I'm going to model the house prices as being something that, the house price depends on the size, the number of rooms, and the number of, does it have a pool? Yes or no? So it can be a 0 or 1 for having a pool. The number of rooms can be an integer number from 1, 2, 3, 4, 5, whatever. And the square meter size as well, it will be a bigger number. Now, how in the past we would do? We will build those expert systems and we will really talk to experts and say, they will say, well, every square meter increases the house price about $3,000. So, okay, so you just learned one part of your model, right? And then we're talking to experts, refining the model, testing them in practice and so on. You're coming up to eventually figure out this model. And this model, we will call a model with 3 parameters. There's 3 things the model captures. And the more parameters it has, the more sophisticated it is. Is the house in the corner? Is the house, newly built on old, existing premise? What is the layout of the room? Is there 2-car parkings or not? But what is the size of the land, size of the house? 2 floors, not. You can think of there can be 100 different parameters, and the more sophisticated model will take all of that into the account. But you can do other way, rather than talking to experts, you should say, okay, give me the data of the past house sale, and I will figure out parameters myself. Rather us writing the intelligent program, specifying the details of the model, we will just give a template. We will just give that template of the model and the data and tell them, you figure out yourself. To give machine, try to figure out the best value for these parameters. So it models the reality best. So we will say, here is the template. This template isn't very complicated, but you can imagine template with 50 parameters, and you learn those parameters from the data. And that's really what machine learning the parameters of the model. And when it comes to neural network, that's one version of this model. It's not a simple model like we showed you before, but it's a slightly more complicated model. So all of these lines in neural networks represent one parameter. So what GPT and all the other new models have billions of parameters. So that's the thing. They're very sophisticated because we deal with a ridiculously large number of parameters. How neural networks work in general, they have certain input data in the first called input layer. Then they will be doing multiplication of the value given to them and compute basically combinations of these different values and eventually produce some results in the output layer. That was the old way of doing things. I mean, it's absolutely fine. However, it's not very sophisticated now. With the deep learning, what they do, they have multiple these intermediate layers. That's what's called deep. Like there is this deep middle part that models some things that are very hard to capture. So if you look at this is an input picture, right, of George Washington. And the input layer, depends how you build it, will, for example, capture the colors of pixels. Every single node will be a color of specific pixel. Then the first layer, combining the pixels, is actually combining to identify the edges. Then the next layer is combining to find different patterns of those edges, combinations of edges to find different shape. The next one is identifying different features of the image, the nose, eyes, whatever. Then the last one is looking at how the different combinations of the features. And then this particular, you can imagine this having a billion parameters. One of these nodes will say, yep, I recognize this is a picture of George Washington. That's how they work. So the depth of this network is giving the ability to recognize complicated things such as edges and shapes and so on. The problem is, it's hard for us to figure this out. This is, a very toy example. Once you imagine trillion parameters, we don't know what they do. It's just a bunch of numbers, a ridiculous large number of different parameters. You don't know how they work, and that's a big problem. Like trying to figure out how a human thinks by looking at the electrons flying around his synapses. It's very hard to make sense of that. This is not how how we think. That's maybe the physically how it happened, but that we really cannot make sense of that. So when we look at, for example, human brain, we don't look at that. We just say, oh, this part of the brain lights up. There is activity in this prefrontal cortex or whatever. We just talk about where is the activity rather than what specific things happen there, because it's very, very complicated. Now, this is all nice and fine, this deep learning. What happened 5 years ago in 2017, a new form of neural networks was developed called transformers. Actually, Google is the first one to develop that. And they're very interesting because they process the data differently. They process, rather than word by word, they process the entire sentences and as input. And originally they were made for text, and they were small. I mean, couple of million parameters, and trained on pre-trained on some data, such as Wikipedia and so on. So some, pretty big data set, but still small in machine learning terms. And then you will get that's called BERT. One of the famous models is called BERT. It's pre-trained on some general public information, but then really to make any sense, to any value of it, you will train on your own data. So that's why there is like 50 different flavors of BERT. There is a BERT for sentiment detection. There is a BERT for sarcasm detection, BERT for all kinds of different things, because you have to train it on a specific domain, because it's still, not smart enough. Now, from 2017 and 18, they realized you can actually use cloud computing for this and graphics cards. So you can parallelize. Up to this point, really everything was on a single computer. Now they were able to split the problem into smaller problems, so it can now run on cluster, a cloud machine. And these models are actually simpler than the old-fashioned neural networks. That allowed the ability to parallelize things allow us to have this general pre-trained models that are just like BERT, but they're pre-trained on ridiculously large amount of data. And if you look at in the last 5 years, the models have been growing exponentially fast. So the size of the models is growing really, really, really fast. So this because you can parallelize, and you can have soccer field full of computers. Yeah, you can build a bigger model. And if you look at, for example, there will be very soon coming the new version of GPT. There will be 100 trillion parameters, which is, the number you cannot even think. The current GPT-3 has 175 billion parameters, which is also mind-blowing. I cannot imagine how something that's 500 times bigger, what are the capabilities of that? And now when we come to ChatGPT, it's just an interface to GPT-3. It's an interface, and the model is slightly improved. So this is, we can call it GPT 3.5, if you want. What's really the whole point of this thing existed for the last few years. It's nothing particularly new. What the new was that the public was able to access that. So rather than you writing a Python code to access GPT, somebody can just go to the website and type the text. So the general public saw, what this thing can do. And the interesting thing when it comes to these technologies is how it works is, receives an input from a user, and what is the input really depends, how your result will be. It almost gave birth to a new field called prompt engineering. How would you structure the text that you give to machine, and ways of structuring that in order to get good results? Because almost like learning how to speak to machine, because now we have a machine that receives the text. It's a human text, but the detail of it, we need to really learn how to speak with them. And keep one thing to keep in mind, like at the moment you see a lot of things talking, ChatGPT cannot do this, cannot generate references. It's too stupid, it confuses certain things. Yes, that's true. But we have everything in place to have this can happen. Parallel structures, it can be parallelized, it has CPU power, it has the data, the capabilities will just grow. And in fact, there is a new version of the new technology called retrieval augmented generation. You can think of almost as shoving the Google in the middle. So you get your query, for example, look at this bottom, Divine Comedy. Explain me the Divine Comedy. And it will split out the query to understand the query. This first part of query encoder will try to parse that. What is it about? Then it will do a Google search and search for a bunch of documents. And eventually it will figure out these purple bits on specific documents, the relevant features. And then it will do almost asking them to summarize what it found. So almost like think of it, you run the query, gets 50 results, and then you run GPT, hey, please, can you summarize this 50 page of results for me? That's how that thing will work. Now that will be, way more powerful and really take into the account the changing nature of knowledge. So to recap, we have the machine learning learning the parameters. There's more parameters you have, the flexible the model is. Training is really trying to figure out these different parameters. And transformers are this new model of neural networks that can that really can utilize the modern computing infrastructures. And because of that, they have billions of parameters and really much faster to work, and really leads to this whole thing that we have today. Now, when it comes to impact on education, I think really we should talk about two kinds of impact. The short one, and obviously assessment is the first bit there. But I think more importantly to think this is huge. This is a change that, one in a lifetime change that happened. What should we learn? What is the point of learning at all? What should we learn? And if you, for example, see South Australia is really amazing in that sense. While other states banned GPT right away because that's the impulsive reaction. It kind of makes sense, right, to do that. Just ban this technology and get kids to do the old-fashioned way. We didn't do that, and in fact, the CEO of Department for Education sent a survey to all the parents. Probably you've seen that. A few weeks ago, there was a survey sent. What do we want from education? The question there didn't mention GPT or anything, but the question was, what do you value in education? Do you value knowledge or lifelong skills or transformative experience of students and so on? So really, they're really thinking about that. What the hell do we want to do with this, with education? How it will look 10 years from now? And now, on the more practical terms, I think I always, while I was researching this, really comes down to three areas where we have AI impact. First is assessment, obviously, how do we assess knowledge, but also teaching support to teachers themselves and learning support to learners. So when it comes to assessment, there are two ways you can go about it, how to deal with GPT and this kind of technology. First, make it harder for AI to help. Try to make assessment that basically that thing cannot do. And first, you can ask him about the things the AI doesn't know about. For example, you have an essay on war and peace. Rather than asking them, write the critical, analysis of war and peace and how these, characters, why they do what they do. No, ask them to summarize the discussion in the classroom. Well, AI can be smart as much as you want, but he wasn't in the classroom, so he won't be able to do that. The only way for AI to do that is for students to write a prompt that will summarize the discussion, in which case the student already did it. So in order for student to cheat, he will have to do it already. So it won't be really considered cheating at that stage. What will AI do will just help with the grammar and maybe structuring it nicely. But we really don't care about that. When you ask somebody to summarize to write a reflection on war and peace, it's not about the grammar. It's about the critically engaging with ideas and concepts. So yeah, it will be fine. The other bit is you can also ask, things that AI doesn't know, and for students to self-reflect on a particular topic. How, reflect on this particular topic, and what do you think, your current experiences, your current, life situation, how that fits that we talk about. Again, AI cannot do that. The only way for students to do it is to, spit out to AI, this is my thoughts on this. This is exactly what we ask them to do, right? So asking things that the AI cannot help. So if you have a generic assessment that doesn't take into the account the current context and the current person, the student, yes, it can automate that, and maybe now makes mistakes with references. But 3 months from now, that will be fixed. So you cannot really rely on that he's stupid now, he cannot do that. That's a very short-term thinking. The other one is embed the AI into the assessment. So assess the process of using AI, because if you think about it, everybody will be using this in job. I can tell you, my wife, she's an office assistant. She uses it every day. So we want to assess how people use this. After all, why would we stop them of using this thing if they're going to be actually use it in the workplace. We are then limiting of them developing the literacy and the knowledge needed to engage with this software. So you can assess the process of using AI. We had a few weeks ago an event on Saturday about AI in teaching and learning. And there was a teacher, Jared Johnson from Pulteney Grammar. He mentioned how he does that, started to do that. He had a student who is not really great in writing. He has great ideas, but he's not able to summarize that. Eventually, the student is using AI to generate the text, write the story. But then what he actually assesses are the prompts. The critical thinking of a student is in the way he writes the prompt, how he sees dialogue with machine. That's where you see the creativity and critical thinking of students in the way he structured the prompt. He says, I don't care about the end product. The story will be good. But that's AI. I'm assessing how this kid is able to use AI in a critical and creative way. And to be honest, it absolutely makes sense to do something like that. So, this is I made up last night, and being a Star Wars fan, I said, can you generate me a story about 3 little piggies in the Star Wars universe? Of course, the story has to start with once upon a time in a galaxy far, far away. And then the story branches, and there is 3 little piggies and the 3 paragraphs about each one of them, right? Okay, if I just show this to a teacher, oh, look how creative I am. No, I'm not. My prompt is very stupid. But if I showed, now this is my next prompt, I want the 3rd piggy to be the evil Sith Lord. Then the AI changes the story. If you now look at the 4th paragraph, the 3rd little piggy, whose name was Darth Vader, was a gifted pilot and a powerful Sith Lord. He changed the story based on my input. So I had to be critical enough to assess, now this original story, that's not exactly what I wanted. I wanted something else. And then I say, okay, I don't want all 3 piggies to be against the Galactic Republic. I want just the 3rd one to be. And then you see the paragraph change. Like, unlike his fellow piggies, the Darth Vader had a different goal in mind. So the AI is changing the story. I'm shaping the story. I'm doing the critical thinking here, right? I'm instructing machine to do something. So if the teacher sees, imagine this like 50 different prompts. This is negotiated story, right? And I had to be really critical and creative to do that, even though I'm actually not writing any words, right? And at some point, probably I will do that because it will be easier for me to just do it myself rather than do it with 50 iterations with machine. But the prompts here and what I'm doing there, I can say, I don't like this. I want it to be more darker. I want it to be like this. I want to have more tension here. I don't like this and that. That's where creativity and critical thinking comes in. Ignore the grammar. That was the old way of doing things because we didn't have anything else to do. But I don't have to do that anymore. When it comes to teaching support, right? So there we have, first of all, about in the area of design and the developing of courses, ultimate creation of a bunch of things, whether it's a study guide, example problems, example questions, things like that, generating assignments, rubrics, course outlines, the weekly plans, whatever. And then you can also have, that's the tool just creating, speeding you up when you're building the courses. The other is the support. So you can help you personalize feedback to students. So you get written assignments, say, hey, can you give a student a feedback on this, but focus on the structuring. And then the AI will come up with something and you might want to tweak that but it will help you to do that. They can automate some of the formative feedback, very quick formative feedback on certain things. Again, I'm talking about, imagine GPT 5 years from now. So it will be able, the current issues, that will be all smoothed out. You can personalize experience. For example, the AI can identify the gaps in student knowledge, different misconceptions, areas for improvement. So then if the AI identifies this student knows well this, but he really struggled with the development of the story arc. That's the area for improvement, right? That's what you will be focusing on. And of course, it can automate grading. And that's probably something that we'll be all very grateful for. So I just gave I was teaching a few years ago a course called The Research Method and Issues in Education. I said, can you generate me an outline for a university course? And this is the outline. I mean, it's a very simple outline, right? But as I as I engage with AI and change the prompts and go back and forth, I can generate a pretty damn good course outline. I mean, even here you see that there is the learning outcomes, the topics for every week, and for example, the AI here is the rest of it. Assume this is an 8-week course. I never said that. I can come back and say, can you generate this to be a 10-week course or 15-week course, and put more emphasis on practical work, and then he will do something there. Assignment, can you generate me the assignment, but change this a little bit, and so on. So it's like almost like having an expert, and you really even you can hire an expert. Like when somebody comes to teaching support, they need to give you back. There is a conversation there, right? It's not like they just tell you what they need and they go away. It's a conversation with an expert before expert can help you. When it comes to student side of things, first of all, the language skill is important help, because there's a there's a certain argument that this will help, for example, the non-native English student, because they will be suddenly able to write in far more sophisticated manner, and remove that problem when it comes to I can be a very creative and smart student, but I'm just not able to my command of English isn't well enough to express myself. It can also help with idea generation. Avoid writer's block, having something to start and work with. Explore different alternatives. You can ask the system to generate a couple of ideas, and then you can then see what you're going to do with that. It can help you with understanding of certain domain. For example, you can do self-testing. I mean, this is the question and answer in mainly question and answer system, but it can do much more than that. So you can ask him, can you give me a test on something? And he will generate the test for you, and you can take that test. So students can do themselves. Summarize the document. Like get a certain topic, a certain document, certain paper, whatever, and say, hey, I don't understand this. Can you summarize this and explain in a different way? Explain solution to a problem. Like, this is the code, this is the question, this is the code. Let's say programming assignment. This is the code that works, why it works. And then the system can tell, oh, these first 2 lines, they do this, then the second 2 lines do that, and so on. Generate alternative solutions. So you write your own solution and say, can you simplify this? Can you give a different solution? And then the student can really learn, grow from that. I just give you this example. This is what I did last night. I want to test my knowledge of Python programming. You will ask me 20 multiple choice questions about Python programming construct. The system comes back, sure, I can do that. Here is the first question. And I put D. Actually, that's incorrect. And the system says, correct. That's wrong. It's actually ChatGPT made a mistake. I said D. In fact, D is the wrong solution. And now if you look at his response, it's correct. The output is 3, 4. If you look at by D, the output is 2, 3, 4. So he completely messed up this in twice. First of all, he should have said it's incorrect. The correct answer is 3, 4. So it does make mistakes, but I mean, ignore that. 6 months from now, this will all be working. Now, that's all fine, but what are the challenges that we really deal with when we engage with these systems? First of all, the training data can be compromised. The training data can be incorrect. So just in a broader sense, like we're training all of this on a bunch of textual information we have on the internet. There'll be big mistakes there, and the system, unless they're able somehow to verify information, that they can make mistakes, especially on something that's very specific that didn't happen many times in the training data. And it can be a bunch of socially unacceptable things. For example, if you train on a bunch of the internet material, well, there'll be some racist things and so on. So how do you filter that? So it requires a human labor there. the system can embed biases that are not apparent so obviously. So already they realize that, for example, when ChatGPT generates something involving teachers, there will be female. When it's about doctors, it will be male. And that's a bias that's easy to identify because gender is so, present everywhere. And it's easy to detect this kind of bias. But what about bias about specific nations, about specific minorities? Bias when, about people with special needs who are also from this specific country, who are also teachers. So that when you have combination of demographic factors, then it becomes not so obvious, right? So when you involve just the gender, yeah, that's easy. But it's very hard to pick up all the biases that exist in the data. Also, dominance of major culture. I mean, when you think about the internet, yeah, there's all kinds of languages, but realistically, there is English and there is Chinese. Like there are two of them consist, 80% of the internet. So by using all of this training data on what's available, you're really propagating the dominating culture online. And that these technologies, of course, require a lot of CO2, generate a lot of carbon footprint because they really require these massive computing infrastructures. And as you noticed in the previous example, they're hard to trust. I mean, at the moment at least, and it's really, we never know what actually happened. Is it what it's doing, right? How can you trust that it will work in some mission critical situation? They are tricky to use. This is the first time we deal with systems that are very flexible in the way they input the data. You can input this way, but you can change slightly and it will still work okay. It really changes the way we engage with machines. Up now, machines were very explicit, right? You need to do it this particular way, and that's the only way. You need to press these set of buttons, and then it will work. And this is far more flexible. And of course, the GPT and other technologies can be used to fool people. Like OpenAI intentionally didn't publish some of the models during the US elections because they were worried they will be able to generate fake stories very, very easily. And that could be, undermine the election. And of course, there's another problem is the ethics of the training data use. Can you really use this training data in the models or not? Should you do that? For example, there have been examples of artists complaining, well, these generative AI technologies, they use my, my paintings as an input. Now they generate something similar. They like fake my, in my style. And on one hand, I fully understand, like you try to have your own, way of artistic style and so on. And then suddenly a stupid machine who does that instead of you. And, you feel cheated in a way. But on the other hand, that's how art was developed over time, right? You have impressionists, the first couple of them put paintings in a gallery. Other kids come around and say, oh, this is cool. And what they do, they start, copying them. That's how you get artistic movement. Everybody copying each other. Copying and replicating others is the essence of any creative process. That's the essence of any artistic movement. But we were okay with that when the humans are doing that. And suddenly we are not okay when machines do that. And there is this disbalance, what to do here. It's very, very strange. What it means to create something, right? The big challenge is really what's creative. For example, the big problem will be copyright. At the moment, you can only copyright something that's been a human, product of human endeavor. Did you create this thing, or a machine created the thing? Who is how do you create something? And ignore GPT. How about Grammarly? You wrote the text, right, the essay or whatever, but this is a sophisticated system that's pretty smart to rephrase your sentences, to simplify, to move even sentences around. It did help you, right? I mean, it's an intelligent spell checker. It's not like in the past. So who really, we're always going to work with machines now, because at the moment we were saying, yep, it's okay to copyright something that you typed on a typewriter or that you typed on a computer because they are dumb machines. They're not doing anything creative. They don't have their own agency. But Grammarly has an agency, GPT has agency, and so on. So it's not really possible to say it's just human doing things. So we will have all kinds of issues there. And the other big one, and George Siemens, there was a session on another panel with Professor Abelardo Pardo and Professor George Siemens. His point was, what is the value of knowing something? And if you think about it, why do we learn anything? We learn because it's useful to know something. And whether it, helps you to act in the world, you learn how to, add and subtract, and then that way you can go to store and calculate how much your bill will be, and learn certain things for employment, right? That's the core of learning, is that. Of course, there is another side. We learn because we want to have that transformative experience. We learn because we want to change, our understanding of ourselves, change our belief system, changes in behavior. So all of this transformative experience of learning is important, and that will probably stay important. But the first bit, probably not. I mean, it will be like playing chess in the future. We know that we cannot beat these new systems in playing chess. We're still going to play chess for fun, but we know we are just fighting for the second place. The first place is AI. So if you want to do certain, generate a story or write an ad or commercial or whatever that is, AI can generate that. We're going to still learn critical thinking because we want to have that transformative experience for us. And thank you so much. And I would like to now take some questions and discuss this further, because this is very all over the place. Hope this was some useful things for you to think about, at least certain things.
Thanks, Vita. That was so much. That was very interesting. There's so much in there, and I think some of the most interesting stuff is not necessarily around the practical applications, but some of the ethical and philosophical questions of the whole thing. So we've had a few questions. I'm just going to go back through the chat and try to capture them all. If you just bear with me a moment. There was a question from Catherine Greenhill around the couple of ethical considerations. So one was around the ethics of setting assessments that require students to use products that capture personal data without a chance to opt out if they want to do the assessments. So there's a ethical question there around privacy and personal data. And secondly, will some of these products have subscription tiers so that richer students will be obviously
absolutely privileged. On one hand, we talk about this is democratizing. If you're not a native speaker, it will help. That's one side of the coin. But the other one is, what if you don't have access to these technologies? And really, it will be a massive, because it's almost like coming to mathematics exam without a calculator. Because if the teacher expects everybody to have a calculator, he will take that into the consideration when he makes an assessment. He will expect you not to have not need to do the all this multiplication and derivations in hand. But the assessment will be much harder for you. So if the teacher makes an assessment and he expects everybody to have access to technologies like this, the bar will just become higher. Pretty much everywhere, we will just lift the bar. And if now you don't have access to this technology, it is just severely impacted. And not just that, if you don't have access to systems like this, your AI literacy will be severely impacted. So, any form of engagement in your workplace in the future, it will be heavily impacted. In comes to tiers, the payment tiers, already I can tell you that I paid my first subscription to OpenAI to ChatGPT last night. It's $22 a month at the moment. So I can tell you right, it's $20 plus GST. So who can pay that, right? That's the absolute question. At the moment, actually, when it comes to students, first of all, the system says you need to be 18 or over. So, for example, in this primary and secondary, technically students shouldn't be using it. The terms and condition of the current platform is whatever you input there, they have a right to use for future training. And of course, that's exactly what they are doing. That's why they open it up to everybody. So there's a buzz, people see what it can do, but they also want your data. There's a huge army of people in Ghana and Nigeria and across Africa. They're really processing manually for $1.50 a day, processing the data to create the training sets and tell, this was good, this was bad, this was good, this was bad, to help them develop this. I mean, there's all kinds of ethical considerations there.
Wow. Yep. There's a lot going on. So, I mean, that whole question of the digital divide we've been hearing about for years, this is just sort of supercharging that.
Yeah, absolutely.
Yeah. Okay. Lauren Hurley asks about people will only actually write better if they learn from the output. How can we ensure/encourage this?
That's that point. Definitely. I mean, like if you think about this example with the story, you are learning. You are, as a student, you're developing your ability to write story by engaging with AI. So really, what you should be focusing on is probably the prompt. And this is all, I mean, it's easy for me to say that, but this is all very new. Like it's really now being tested as we speak. Some of more innovative teachers will be trying that, and it probably take you a few months or a few years to know what to do with it. I mean, even when calculator showed up first time, people didn't know what to do. Should we ban them? I mean, it really up to 80s. There were discussions: should we ban calculators or not? I mean, it took about 30 years for just a stupid calculator. I mean, can you imagine, impact of something like this? We really don't know. But I see a lot of impact like COVID. When COVID happened, how are we going to switch everything online? The first few months it was a mess, but eventually teachers picked up. Quickly, everybody realized that having kids sit from 9 to 3 in classroom online was a bad idea. So then they identify those daily check-ins and activities. Teachers are quick to pick up what works, what doesn't work. So it will take a bit of time before we know what to do. Now, the good question is, for example, are you as a teacher allowed to put, for example, student essay? You want to grade, and you wrote this nice fancy prompt that will do automated grading with a specific rubric in mind. Can you really post that into GPT? Because when you do that, the data will go to OpenAI, and now they have it. So, but the good thing about this is you will be able to run these systems on campus. I'm absolutely certain in the future you will have GPT installation on campus, because they're not that complicated. If you think about it, the technology isn't so complicated. It's just massive. It's more of a brutalizing in size. The complexity itself isn't that hard to wrap around. So I think we will see, for example, UniSA GPT server, and we will be able to do whatever we want there, of course, because then the data doesn't leave. Or there will be some certain arrangement made with companies. Like, for example, when we are able to send the data to Amazon Cloud or Microsoft Cloud, because there is special legal things protecting that. But at the moment, there's a big challenge there.
Great. Alison Crozier asked the inevitable workload question, and you kind of touched on that just then, Vita. How do we find space, time to teach students how to use this AI appropriately when there's so much a course is already overloaded?
That's a great point. I mean, on one hand, it does help you, right? But on the other hand, just trying it out is not helping you. So you really need to find time to carve the time to play around with this. I guess, I mean, professional development will be a massive area of professional development for everybody. I mean, we see, for example, in C3L Center, we get massive demand from schools, for their teachers. I mean, I'll pretty see that similarly at university level, the teaching innovation unit and other will have a lot to say about this, because you'll need some champions who know how this thing works and can help you get to speed. Because It will be a lot. I mean, but I think the benefit, at least in some areas, are so clear. Like, for example, providing feedback, summarizing things, generating certain materials. For example, me and my colleague, we used it to generate a course outline for one course. It wasn't perfect, but it gave us a pretty good rough draft that we then changed, expanded, and so on. I mean, even with our very limited knowledge of how to write prompts, it worked pretty okay. So I think people will quickly, realize the easy win.
Okay, Richard Levy asks, who owns the copyright on AI-generated content?
That's a fantastic point that I mentioned. At the moment, I don't know. To be honest, who owns the copyright on ChatGPT? Don't know, but who owns on all the other systems? I mean, this is just one of them. It really depends on a specific system. How did you, when you upload a picture to Facebook, who owns the photo now? And it depends on a platform by platform. So it will be a system by system, but it's really, how this is a major problem will be in the future, because it's really messing up everything.
Yeah, watch this space. There's a question, it's quite a long one. If AI is always learning and developing itself, will it come to a point where the need to prompt will be less due to the growth of data input and a possible control of idea generating from the AI? Or could the company that owns the AI generate input to always generate a certain idea?
Oh, absolutely. They do that. And for example, I was just goofing around and said, hey, can you write me, what was that? Can you write me a pickup line? The system didn't want to do that. It says, that's not what you should be doing. I said, no, I just want to get no, the system doesn't allow it. So there is an embedded ethics and morality in the system, right? They really capture the first of all, the training data, but also the organization that owns the system. So they embed certain moral and ethical principles there, and it's a major thing how this will shape the total, the things we do, right? You think you are being creative and you're generating the story, but imagine that the system is always generating, 90% of the time generating the story where, Americans are good guys, but Chinese are bad guys. You won't even notice maybe this would be too obvious, or, but some more subtle things like that. And you write a story, hey, here is my new movie script. There is a, Chinese gangster again, right? So it will be how we will realize. I mean, that will be almost like subconsciously providing us with a certain thing. And then that you think you are generating ideas, but in fact, you on almost to an extent, you're being manipulated, because the things being provided to you are not just depending on your input, but all the other people involved in building the system. So it's a major danger in how this will go. And I guess probably what will happen with the training, or the thing about the less need for prompt, probably that's true, because if you imagine that you have your own, learning designer in residence, he will be able to much faster help you than somebody that you meet for the first time. He will know who you are. He will have a context. So if this system is able to keep the track of history, that's a clever thing about ChatGPT. It does remember history, about 20 different prompts. So about 20 prompts, he will remember. Then it starts to forget. Imagine a system that remembers 1,000 prompts. So then it will say, hey, I'm teaching again this stupid course in, next spring. Can you generate me something very similar like we did last time? I even didn't mention what is the course about, right? He will know to pick up from the context. So probably that will be less need for long prompts if they know who we are.
Okay, thanks very much, Vito. We're kind of coming to the end here, and I think I've covered all of the questions. There's been a lot of comments, and it's a little bit difficult to keep up with the chat, which has been quite busy. A couple of things in there. George Siemens has posted a couple of links on some additional webinars or presentations coming from the C3L group. So if you're interested in in getting some more information, please look at the chat, and I think he's posted a couple of links there. So thanks for that, George. Now he's plugging C3L. Thanks, George. I'd just like to say a huge thanks to you, Vito. That was fascinating, and yeah, it raises so many questions, and we've all got a lot of challenges, but I think ultimately we have some amazing opportunities, especially in higher education. And yes, Vicky, we will be providing some professional development. What that looks like, we're still working through that. We might get that written by ChatGPT. We'll see how we go with that. So once again, thanks very much to you, Vito. We really appreciate you taking the time. We know you're super busy. And thanks everybody for coming along from all around the world and around Australia. We really appreciate it. We'll be sending out a link to this recording a little bit later on today. So please feel free to send that to whoever you like. And again, good morning and have a great day or a great evening, wherever you happen to be. And thanks very much, Vito. That was fantastic.
Yeah.
We really appreciate it.
My pleasure. Yeah, thanks for the invite.
No worries. Goodbye, everybody. Have a great day.
Thanks. Bye.